Welcome to our comprehensive guide for the Databricks Certified Data Engineer Associate exam, focusing on Section 2, Development and Ingestion. I'm your host from @DataOpsGuy, and today we'll dive deep into the core concepts that make up 30% of your certification exam. Section 2 covers 5 critical areas that every data engineer must master. First, we'll explore how to use Databricks Connect in data engineering workflows, enabling you to develop locally while leveraging cloud compute power. Second, we'll examine the powerful capabilities of Databricks Notebooks and how they facilitate collaborative development. Next, we'll classify valid autoloader sources and understand their use cases for efficient data ingestion. We'll then demonstrate autoloader syntax for both PySpark and SQL implementations. Finally, we'll learn to use Databricks' built-in debugging tools to troubleshoot issues effectively. Each topic we cover today directly relates to real-world data engineering scenarios you'll encounter in production environments. Let's begin this journey to certification success. Databricks Connect is a game-changer for data engineers who want to maintain their local development workflow while harnessing the power of cloud-based Spark clusters. Think of it as a bridge between your favorite IDE and Databricks' massive compute resources. With Databricks Connect, you can write code in PyCharm, VS Code, or any IDE you prefer, then execute that code on a remote Databricks cluster. This means you get the best of both worlds, familiar development tools and enterprise-scale processing power. The setup process is straightforward. First, install the Databricks Connect library using pip, ensuring the version matches your cluster's runtime. Then configure the connection by providing your workspace URL, personal access token, and cluster ID. Key use cases include local development and testing, where you can run unit tests against live data, CI/CD integration for automated testing, and building custom applications that leverage Databricks compute. Remember, for the exam, focus on understanding configuration requirements and common troubleshooting scenarios. Databricks notebooks are the heart of collaborative data engineering in the platform. These aren't just simple code editors. They're sophisticated environments that support multiple programming languages, real-time collaboration, and advanced features that streamline your workflow. One of the most powerful features is multi-language support. You can seamlessly switch between Python, SQL, Scala, and R within the same notebook using magic commands. This flexibility allows you to use the right tool for each task without leaving your development environment. Real-time collaboration means multiple team members can edit the same notebook simultaneously, seeing each other's changes instantly. The automatic versioning system tracks every change, allowing you to revert to previous versions or compare different iterations. The Databricks Assistant, powered by AI, can generate code, explain errors, and suggest optimizations. Built-in visualizations let you create charts and graphs without external libraries, while widgets enable interactive parameters for dynamic notebooks. For the exam, remember that notebooks integrate with Git repositories, support library management, and can be chained together for complex workflows. Autoloader is Databricks' solution for efficiently processing new data files as they arrive in cloud storage. It's designed to handle one of the most common challenges in data engineering, continuously ingesting streaming data from file-based sources. Autoloader supports 3 major cloud storage platforms: Amazon S3 with its various storage classes and event notifications, Azure Data Lake Storage, Gen 2 with hierarchical namespace and event grid integration, and Google Cloud Storage with pub/sub notifications for real-time file detection. The key use cases span the entire data ingestion spectrum. For incremental data ingestion, Autoloader continuously monitors your storage locations and processes new files as they arrive. For backfilling historical data, it can efficiently process large volumes of existing files. Schema evolution is handled automatically, adapting to changes in your data structure without manual intervention. What makes Autoloader particularly powerful is its ability to provide exactly once processing guarantees while maintaining high throughput. It uses cloud-native notification services for near real-time file detection, making it ideal for modern data architectures. For the exam, focus on understanding which storage services are supported and the common patterns for implementing Autoloader in different scenarios. Understanding Autoloader syntax is crucial for implementing efficient data ingestion pipelines. Autoloader uses the Cloud Files format in Spark structured streaming, providing a unified interface regardless of your cloud provider. The basic PySpark syntax follows a familiar pattern. You start with spark.readstream, specify the Cloud Files format, configure your options, and load from your source path. Key options include cloudfiles.format for your source file type, cloudfiles.schema location for storing schema information, and cloudfiles.use notifications for enabling real-time file detection. For SQL users, the cloud_files function provides the same functionality with a more declarative syntax. You can create streaming tables directly using the cloud_files function with a map of configuration options. Essential configuration options control performance and behavior. Cloudfiles.maxFiles per trigger limits how many files are processed in each batch, preventing overwhelming your cluster. Cloudfiles.schema evolution mode determines how schema changes are handled, and Cloudfiles.rescue data column captures malformed records for later analysis. The beauty of autoloader syntax is its consistency across different file formats and cloud providers. Whether you're processing JSON from S3, CSV from Azure, or Parquet from GCS, the syntax remains largely the same, with format-specific options added as needed. Effective debugging is essential for maintaining robust data pipelines, and Databricks provides a comprehensive suite of built-in tools to help you identify and resolve issues quickly. The interactive Python debugger is your first line of defense for code-level issues. You can set breakpoints, step through code execution, and inspect variables in real time. Use the %debug magic command to enter the debugger, or set conditional breakpoints for specific scenarios. The Spark UI provides deep insights into job execution and performance. Access it through your cluster page to examine job stages, task distribution, and identify bottlenecks. The SQL tab shows query execution plans, while the Storage tab monitors cached data and memory usage. Driver and executor logs contain detailed error information and stack traces. You can access these logs directly from the cluster page, or programmatically search for specific error patterns. For production workloads, implement structured logging to make troubleshooting more efficient. Job run history helps you identify patterns and recurring issues across multiple executions. This is particularly valuable for scheduled jobs where intermittent failures might indicate resource constraints or data quality issues. Remember for the exam, know how to access each debugging tool and understand what types of issues each tool is best suited to diagnose. As we wrap up our deep dive into Section 2, let's focus on key strategies for exam success. This section represents 30% of your certification exam, so mastering these concepts is crucial. For Databricks Connect, understand the configuration process and common troubleshooting scenarios. Know when to use Databricks Connect versus working directly in notebooks, and be familiar with version compatibility requirements. For notebooks functionality, focus on collaboration features, version control integration, and the various magic commands. Understand how widgets work and how notebooks can be chained together in workflows. Autoloader questions will test your knowledge of supported sources, configuration options, and syntax differences between PySpark and SQL. Pay special attention to schema evolution modes and performance tuning options. For debugging tools, know which tool to use for different types of issues. Understand how to access the Spark UI, interpret job metrics, and use the interactive debugger effectively. Let's look at a sample question. Which of the following is a feature of Autoloader? The correct answer is B-. Efficiently handles source schema changes. This highlights Autoloader's automatic schema evolution capability, which is one of its key differentiators. Practice with hands-on scenarios, review the official documentation, and join study groups to discuss complex concepts. Remember, the exam tests practical knowledge, so focus on real-world applications of these tools and techniques. Good luck with your certification journey, and remember to follow @DataOpsGuy for more data engineering insights and exam preparation tips.